Finally, the last component we're going to talk about here in part one is going to be the injector, the G2 injector. Okay, like I said, the G2 injector is a Huey style injector, but it's got a lot of variances if you compare that to the CAT or a 7.3 or a DT466 injector. In this case, what we're looking at here is the spool valve. The spool valve is the key here. So as you can see, you got oil coming in from the top. Now, if you remember from the previous pictures, if not, rewind it back, you could see it. We saw that there's an oil rail on top of the injector. So these are top-fed hydraulic pressure to the injectors. Okay, so there's a nipple that goes in here. Now, we see that here and here, right? So in this case, the high pressure oil goes in here. Now, on the top, you're going to see two solenoids. That's why I left this picture here. Here we can see one solenoid. Here we can see another solenoid. There's two solenoids here. And those solenoids get 48 volts from the ficum. So the ficum is providing power there, okay? And what is its purpose is to become an electromagnet. What it does is that it actually moves the spool valve. So let me zoom in here. Now this spool valve moves from side to side, left to right. Only a few thousandths of an inch. It travels click, 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 click. That's why I hate it when people call it, I'm technical about this stuff. People call the key on engine off injector injector test as the buzz. No, buzz would be a 7.3. For a Powerstroke 6-liter, it's a click test because it's click, 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 and that's what you're going to hear. Click, click, click when you run the key on engine off injector self-test. So this spool valve is moving side to side to side to side. So what moves it is here's one solenoid and here's another solenoid. Applied how many volts? 48. Okay, so this one moves it. So when we talk about stiction, it only applies to the 6-liter injector or the G2 injector or the other models that use it, like the newer DT466 uses a bigger version of this injector. So in this case, this is moving back and forth, back and forth. So in cold starts, you're going to find out it mostly occurs, so it gets sticky. So what attributes to the life of a stiction-free truck or stiction-free injector is frequent oil changes once again. Okay, oil changes helps prevent that. So do I have stiction on my truck with 117,000? No, because again, I'm very good about changing the oil. So in this case, that is got high pressure oil coming in here, controlling oil pressure to the intensifier piston. So here we see our intensifier piston. Now at the bottom of the piston, there's a rod that has fuel coming in. So the fuel feed is on the side. That's where we see fuel coming in on the injector. So if I backtrack on this, this would be our fuel inlet. You'll see an O-ring here. You'll see an O-ring here. So in the cylinder head, there's a passage that supplies that fuel coming in at 55 PSI, like we said, okay? So that fuel, let me zoom this up again, my apologies here. That fuel is going to be pressurized by the intensifier piston pushing down, and it'll pressurize that fuel going to the nozzle. Now this nozzle is seated thanks to this spring right here. So this spring pushes down on this nozzle right here, okay? So it's closed, it's seated. Now how do we get it up? Well, what we do is we pressurize this fuel coming in from the intensifier piston thanks to the ICP pressure pushing down on it. It's pressurizing the fuel coming in, and what's happening is that the pressure will get so high up here that it's going to overcome the spring pressure and lift the nozzle upward, okay? Once it goes upward, what it's going to do is through the nozzle holes, now those nozzle holes are exposed to fuel and fuel will be injected. Roughly, it starts at around 3,100 PSI is what we see coming out of here at the nozzles. Make sense? So once the intensifier piston has had the hydraulic pressure or ICP pressure relieved, the spool valve is closed, so now the pressure will actually bleed out through the passages. So what is on top of the injector, you're going to see, and I don't think I have a good picture of it here, but on top of the injector, you see two other holes right there, and that is your exhaust pressure coming out. So that will be exhausted into the valve train area. So again, high pressure oil comes in. The spool valve is actuated because the coil energized with 48 volts, moved it to the side. High pressure oil came down, pushed down on the intensifier piston, which overcome the spring pressure. Pressurize the fuel coming in at 55 PSI. That pressurized fuel will be high enough to overcome the spring. The nozzle will lift, and injector hose will be exposed, thus injecting fuel into the cylinder. Please note, 6 liters do not have pilot or post injection like a common rail does, or the late model injectors used on 7.3s where we had 2 injection events taking place. No, in this case, it's 1 injection event you're going to see. That's why they're so loud, these 6 liters. A lot of it has a tribute to that because we call that the diesel knocking sound, which is normal. So that's basically it. Okay, one more time. High pressure ICP pressure comes in. The FICM is controlling the solenoids right here. We're supplying 48 volts that once energized, they become electromagnets. They either are opening or closing, thus moving this spool valve left to right, depending if you want to open or close. When open, high pressure will come down the intensifier piston. It'll overcome the spring rate. And then at that point, it'll pressurize the fuel. That pressurized fuel will overcome the spring on top of the nozzle. The nozzle will lift at this point. That's what's happening. And then injection will occur. When injection is over, the FICM will go ahead and close the spool valve by energizing the closed coil. At that point, the spring from the bottom intensifier piston will now overcome that ICP pressure because it's now closed and relieve it out the exhaust ports on top of the injector that we see there. So there you go. Now, please note, like we said, that spool valve only not even 17 thousandths of an inch. You know, it actually moves from left to right there. So in summarization, before we show you, because the next thing we're going to show you after this is we're going to show you the diagnosis on the truck, just looking at this data that you need to know. So what do I need to know? I need to know ICP voltage and ICP pressure, but I need to know desired. I can look at the duty cycle of the IPR, but your job as a person is to look at your oil pressure gauge. If you've got a crank no start, tell me if that oil pressure gauge is working. So we got any oil coming in, because you cannot get high pressure oil unless you get some oil from the oil pump. There you go. So that G2 injector needs 55 PSI. So you need to verify and measure that 55 PSI. And then we got the computer side of things where I can look at some basic data. I need to look at the sink PID, see if I got a FICM sink, and obviously if I got a pulse width going towards the injector. So you can see all that on the scan tool. Always remember, like I said at the beginning, this will only work if you also make sure you got good compression. Okay, so that's why we use the power balance test. In case the engine does run, it runs rough, I can use the power balance test to know which cylinders are weaker than others, or if I got a misfire. So let's look at that IDS sync. Excuse me, let's look at that IDS screens on the truck, and hopefully you learned something. Thanks for watching.
All right, another critical test with Powerstroke 6 liter is the power balance test. There are more and more scan tools. This is the Ford IDS program I'm using, but there are more and more scan tools that will allow you to do the power balance graph. And this is worth everything that we use to diagnose. What I'm going to do is I'm going to squeeze the graph a little bit here. And in this case, I'm in injector kill mode too. So this truck has 117,000 miles on it. It's got the original injector, so it isn't surprising to see some fluctuation and change. But we have an erase button here. And what I'm looking at here is what's going on with the performance of each injector. Now, the input that is used to know what each injector or each cylinder, better yet, is doing is based on crankshaft position. So we're looking at that. So in this case, I can go ahead and kill one cylinder at a time. So there's number 1. There's number 2, and I keep going in through the firing order. Now, as I'm doing these, you're going to notice that it leaves a signature. And by leaving a signature, I can evaluate if all the cylinders are pretty much working evenly. So in this case, there's number 6, and we can finally get to number 8. And yes, I could feel a vibration as I'm doing this. So what am I looking at? They're all dropping just about evenly, okay? So therefore, that will allow me to say, hey, all these cylinders are working pretty much close. Now, let me erase this. Now, when we actually diagnose stiction issues where the spool valve on top of the injectors is sticking, in this case, we are going to evaluate the graph. So most of the time that we diagnose stiction, It occurs when the engine is cold. So we'll go on a cold start, turn the key on, we'll set up the graph here, and boom, as soon as I fire, I will see which cylinder is misfiring or has stiction going on in it, so I can nail which is the problem. Because many trucks that have stiction, well, it will only occur, the miss, when the engine is cold. Within 40 seconds, it's already gone. So maybe it'll intermittently drop, but you know, you can't catch it. So here we can see what the history of each cylinder is doing. We can see they're all pretty much working. It's like a little ocean wave moving across, but they're all working pretty good. Now, I know that we just showed you a cylinder kill. Let me kill number 3 again. And you can see there's an RPM drop right there, right? So we dropped RPM because I killed that injector. In other words, we did a balance test. Now, can you get trucks that will have actually peaks? And the answer is yes, you can have peaks. And if you have peaks instead of valleys, that means that injector is most likely overfueling or leaking. That's the ones you got to be fear of. Or it could actually have another fuel source. What is another fuel source? You can have a lot of oil mixed with fuel in the charged air cooler and starting to suck in, and it's a potential runaway condition. Yes, we've had 6 liters run away twice, at least in my life. So in this case, if you see a peak instead of a valley, that means that injector is overfueling, that cylinder is overpowering the rest. Again, it could be injector, or it could be what? It could be that it's got an external fuel source, like I said. That's why for high mileage 6.0s, we tell them to remove the bottom hose of the charged air cooler, see if we got the presence of excess oil mixed with fuel. So watch out for that. So there you go. That is a good example of a power balance test.